On this question, we want to evaluate f over g of 0, given that f of x is equal to square root x plus 4, and g of x is equal to x squared minus 6. Now, there are a couple ways we can approach solving this problem. We want to evaluate f over g of 0. So if we want to evaluate, that means that we want to substitute this 0 into the function f over g. We don't have that function f over g, but we do have the function f in the function g. F over g can be built or constructed from these individual functions, and then we can evaluate. So that's one approach. So one approach is that we construct the function f over g of x, and then once we construct that function, we can do the evaluation of f over g of 0. So let's take that approach, and then I'll show you a second approach that we could take. So if I want to construct f over g of x, I'm going to take the function f and divide it by the function g. And so I'm basically using the name of the function as instructions on how to construct it. The name of the function is f over g, or f divided by g, and so to construct that function, I'll take the function f and divide it by the function g. F of x is equal to x plus 4, so that goes in the numerator, and g of x is x squared minus 6, that goes in the denominator. And as I look at this, there's not really a whole lot of simplification I can do, so I'm going to leave f over g as square root of x plus 4 over x squared minus 6. So I've constructed that function, and now I want to evaluate f over g of 0. This is the square root of 0 plus 4 over 0 squared minus 6. That's the square root of 4 over negative 6. The square root of 4 is 2 over negative 6, and we can reduce this down to negative 1/3 because both 2 and 6 are even, so 2 goes into 2 once, 2 goes into 6 3 times. So we found f over g of 0 to be negative 1/3. So now I'm going to show you another approach that we can take, and that is to use these symbols, f over g of 0, and we're going to use the definition of f over g of 0, which is f of 0 over g of 0. And this tells me that I can calculate f of 0, calculate g of 0, and then divide to get the answer. So f of 0 is square root of 0 plus 4. G of 0 is 0 squared minus 6, and I've written them in the numerator and denominator because I intend to divide them. So that gives me square root of 4 over negative 6. Square root of 4 is 2 over negative 6, and then we can reduce to get negative 1/3. So this second method allows you to avoid having to construct that function f over g of x that we did right here. Either method gives us a solution of negative 1/3. On this question, we let f of x equal negative 5x minus 1 and h of x equal 3 over x minus 4. We want to find h composed with f of negative 5. So I have two different methods I'm going to show you to calculate or find h composed with f of negative 5. So first of all, we have this notation, h of f. This is the name of a function, and the -5 is a value that we want to evaluate the function at. So the first method that I could use to find h composed with f of -5 is to construct this function. I could construct h composed with f of x, and once I've constructed that function, I would evaluate h composed with f of -5. So in order for us to construct this function, h composed with f of x, we have to know what that operation of composition actually means. And that operation of composition is when you substitute one function inside of another function. So for this one, it means h would be the outside function because it's written in front of the composition symbol, and f will be the inside function because it's written after the composition symbol. So we would want to construct this function by substituting f into h. So that would give 3 over, and in place of this x here, I'm going to substitute f of x. That's -5x minus 1 minus 4. And we'll simplify. This is 3 over -5 minus 5. Excuse me, that's -5x minus 5. So now we've constructed the function, and then we'll evaluate h composed with f of -5. We'll substitute that -5 into the function to get 3 over -5 times -5 minus 5. That's 3 over positive 25 minus 5, and that's 3 over 20. And that's the lowest term, so I'm going to leave it like that. So that's one way for us to find h composed with f of -5. So the other way to do it is to follow the definition of the symbols. So that's h composed with f of -5. And as I said a moment ago, the operation of composition means that we want to substitute one function inside of the other function. So I can rewrite this using that definition. H is the outside function, f is the inside function, and we evaluate the inside function at -5. So I'm going to start by looking on the innermost parentheses, and that gives me instructions on what to do. F of -5 means that we're going to substitute -5 into the function f. So I'm going to substitute -5 in for this spot here. So that would be -5 times -5 minus 1. -5 times -5 is 25 minus 1. And 25 minus 1 is 24. Once I've simplified inside that parenthesis, now I'm going to look at all of these symbols, and I have h of 24. So I'm going to evaluate the function h at a value of 24. So in for this spot right here, I'm substituting the 24. That's 3 over 24 minus 4. That's 3 over 20. And we've got the same answer from before, 3 over 20, and that is in lowest terms. On this question, we want to use the quadratic function f of x equals 2x squared plus 4x minus 1 to address the following. We want to find any x-intercepts and any y-intercepts. So let's start with part A, which is to find the x-intercepts. You find an x-intercept by letting y equal 0. And when you look at our function, we have f of x equals 2x squared plus 4x minus 1, and you don't see a y. But what you have to keep in mind is that f of x stands in for y. We've just given this function a name of f. So we're going to set this whole function equal to 0 and try to solve this quadratic equation. It's a quadratic equation because we have that squared there. So I'm going to start solving this. I'll try to solve it by factoring, and if I'm not able to factor it, then I'm going to try to use the quadratic formula. So if I start to try to factor, in this first position I would need 2x and x. 2x and x would multiply to be 2x squared. And in this last position, in each binomial, I would need a 1 because 1 times 1 would give me the 1 on the end. And when I check, I'm going to check the multiplication for the outside and the multiplication for the inside to see if I get the middle term. On the inside, I would get 1x, and on the outside, I would get 2x. And if I combine those together with either adding or subtracting, neither one of them will give me the 4 in the middle. Since these numbers in the front, 2, and the number in the back, 1, are both prime numbers, there aren't really any other pairs or arrangements that I could use for factoring. So this quadratic cannot be factored. So I'm going to use the quadratic formula to find the x-intercepts. So the quadratic formula uses the coefficients of the squared term a, the coefficient of the linear term b, and the constant c in this formula here. X equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So we're going to substitute our coefficients into this formula. That gives negative 4 plus or minus the square root of 4 squared minus 4 times 2 times negative 1 all over 2 times 2. I'm going to move up here and start simplifying, and when I simplify, I'll use order of operations. So inside of the radical, I'm going to apply the exponent first. 4 squared is 16, and I can do that multiplication. 4 times 2 is 8, times 1 is 8, and we have an even number of negatives, so that will be a positive. In the denominator, 2 times 2 is 4. I'm still working inside the radical. It's grouping that together. 16 plus 8 would be 24 over 4. Then I want to try to simplify the radical. When I simplify the radical, I'm looking for perfect square factors. And for 24, if I think about those factors, got 1 times 24, 2 times 12, 3 times 8, 4 times 6, and I think that's the last pair. So I'm going to use 4 times 6 because 4 is a perfect square. So 4 times 6, the same thing as 24. I can now simplify the square root of 4. The square root of 4 is 2. The 6 is not a perfect square, so we leave that inside the radical. And then finally, we have a fraction here, And with fractions, you always want to write the fraction with no common factors. And I can see that 4, 2, and 4 are all even numbers. So I'm going to be able to cancel out a common factor of 2 from each one of those terms. And we have negative 2 plus or minus square root of 6 over 2. So those are our x-intercepts. We have 2 of them. Negative 2 plus square root of 6 over 2, and negative 2 minus square root of 6 over 2. So then we want to find our y-intercepts. To find the y-intercept, you let x equal 0. I'm going to substitute a 0 into the function, which would give 2 times 2 squared plus 4. I misspoke there. 2 times 0 squared plus 4 times 0 minus 1. And 0 squared is 0, times 2 is 0, 4 times 0 is 0. And we end up with 0 plus 0 minus 1, which is negative 1. So our y-intercept is negative 1. Right-cut riding lawnmowers obey the demand equation P equals negative 1/10 x plus 1,750. The cost of producing x lawnmowers is given by the function C of x equals 150x plus 4,000. Express the revenue as a function of x. Express the profit as a function of x. Find the value of x that maximizes the profit. What is the maximum profit? What price should be charged in order to maximize the profit? So we have a lot to do in this question. But we're going to start with part A. And part A requires us to have a business formula for revenue. And that business formula is that R equals XP. Revenue is the number of units times the price of the units. Now the demand equation was given to us at the beginning of the question, and we're going to be able to substitute in for that P so that the only variable in our revenue function is X. Right now we have variables of X and P. So for part A, we're using that formula revenue equals X times P, and then substituting the demand equation in for P, the price. So that's X times negative 1/10 X plus 1,750. We can simplify that using the distributive property. That's negative 1/10 X squared plus 1,750x. So we now have our revenue function. And in part B, it says express the profit P as a function of X. Now this might be a little bit confusing because we're using P for price and P for profit, but we use the lowercase p for price and the uppercase P for profit. We also have another business formula that we need, and that is that profit, that's a capital P, is revenue minus cost. So in part A, we built the revenue function, and earlier in the problem, we were given the cost function. So we will be able to find the profit function. Profit is revenue minus cost. I'm going to substitute the revenue that we came up with in part A, 1/10 X squared plus 1,750X minus the cost that was given above, and I need to make sure that I am subtracting the whole cost function and not just the first term of the cost function. So I'm putting a parenthesis so I can subtract the whole function. That's 150x plus 4,000. I'll distribute that negative. That's 1/10 x squared plus 1,750. 150x minus 4,000. And I'll combine like terms. That's negative 1/10 x squared. And 1,750 minus 150 would be 1,600x minus 4,000. So we now have the profit function. Profit as a function of x, which means that x is the only variable in that function. So in the next part, it says find the value of x that maximizes profit. What is the maximum profit? So this part can be a little bit confusing, but I'm going to explain the logic of how we get to the maximum profit. So what we notice about our profit function is that it is a quadratic. We know it's a quadratic because of that squared. So our profit function is a quadratic. And the graph of a quadratic is a parabola. And we have two types of parabolas. We have an up-facing parabola and a down-facing parabola. If we have our leading coefficient being positive, we get the up-facing parabola. And if the leading coefficient is negative, we get the down-facing parabola. So let's take a look at our coefficient. Our coefficient is negative 1/10. That's negative, so we know that we have the down-facing parabola. And when we have that down-facing parabola, I know the maximum y value, the maximum profit, will occur at this little peak here. And that peak has a special name called the vertex. So the max is going to occur at that vertex. So I can find the maximum value of this function if I can find the vertex of this function. So we do have a formula for finding the vertex, and that formula is the vertex is an ordered pair. We usually label it with HK, and we can find the x-coordinate of that vertex, h, by doing negative b over 2a. And then the y part we'll get by substituting this value into the profit function. So for our example, a is negative 1/10, b is 1,600, and c is negative 4,000. So I'm going to find the vertex, HK. H is negative b over 2a. That's negative 1,600 over 2 times negative 1/10. I'm going to get my calculator to help me with this. Okay, so I have my calculator here, and I'm going to, for the numerator, type negative 1,600. We're going to divide that, and I need parentheses around the whole denominator. 2 times negative 1/10, and close parentheses for the denominator. So we have 8,000. And then I want to find the y-coordinate of the vertex by substituting into the profit function. So I'm going to find k by evaluating profit at 8,000. So I'm substituting that 8,000 into the profit function, which would give me negative 1/10 times 8,000 squared. I'm just going to double check because I wrote 800. Okay, it's 8,000. Okay. Plus 1,600 times 8,000 minus 4,000. And once again, I'm going to bring back my calculator. We'll type it in. We got negative 1/10 times 8,000 squared plus 1,600 times 8,000 minus 4,000. And that gives 6,396,000. I'm going to zoom out just a little bit so we can read the question again. And I'm taking a look at part C. So the work we're doing here is for part C. And in part C it says, find the value of X that maximizes the profit. What is the maximum profit? So the value of X is 8,000 and the maximum profit is the 6,396,000. So we get a max profit of 6,396,000 by selling 8,000 units. So we have one more part to go. What is the price? What price should be charged in order to maximize the profit? Remember that price is that lowercase p that we saw in the demand equation at the beginning. So let me zoom out again so you can see that. I'm going to highlight the demand equation, which represents the price. And the variable that's used in the demand equation is X. We just found that an X number of units, 8,000 units, maximizes the profit. So the price that maximizes profit is going to use that same value of X. So we're going to evaluate the demand function at a value of 8,000. So for part D, we're using the demand equation, negative 1/10 X plus 1,750. And since selling 8,000 units maximizes the profit, the price that we should charge will use that 8,000 units. We have negative 1/10 times 8,000 plus 1,750. We'll use our calculator again. And we have negative 1/10 times 8,000 plus 1,750. So we should charge $950 per unit to maximize the profit. For this question, we want to find all vertical asymptotes and create a rough sketch of the graph near each asymptote. We want to do this for the function f of x equals 8 over x minus 3. Now, when we're looking for vertical asymptotes, we first need to make sure that our function is in lowest terms, which means that there are no common factors. In this example, 8 is in factored form, x minus 3 is in factored form, and I see no common factors. So I already know that this function is in lowest terms. Once it's in lowest terms, I'm going to set the denominator equal to 0 and solve. So I said x minus 3 is equal to 0. I'm adding 3 to both sides to get x equals 3. So this is a restricted value for the function, and it is also the vertical asymptote. So we have a vertical asymptote for this function at the restricted value of x equals 3. Now I want to create a rough sketch of the graph near the asymptote. And to draw a rough sketch, I need to understand what it actually means to be a vertical asymptote. So to be a vertical asymptote, that means that as x is approaching the value of 3, your y is either going to approach infinity or it's going to approach negative infinity. So what I know is that at that location of 3, the y, I'm going to use a little dashed line to represent where the vertical asymptote is, the y will either approach infinity or negative infinity on the right-hand side, or it will approach infinity or negative infinity on the left-hand side. We have to figure out which one it is. It can only be one of these, and it can only be one of these. So what I'm going to do is choose some test values to help me understand which one it is. So I need to choose a value that is slightly smaller than 3. So we say 3 minus, and we need to pick a number that is slightly larger than 3, which we call 3 plus. And for 3 minus, I'm going to choose the number 2.9. And I'll substitute that into the function. F of 2.9 is 8 over 2.9 minus 3. And in the numerator, that's a positive number. And in the denominator, 2.9 minus 3 is going to be a negative 0.1. So I know that this is negative. And that tells me that this one right here is the right choice because that's going to negative infinity. So let's get rid of this one right here. For 3 plus, I'm going to choose the value just slightly larger than 3, 3.1. That's f of 3.1, 8 over 3.1 minus 3, 8 over 0.1. This is a positive divided by a positive, which is a positive. So I know that's going to positive infinity, and this one is the right choice for the right side of 3, or above 3. So let's get rid of this one over here. So now I have a sketch of what's going on near the x value of 3, near that vertical asymptote at 3. Sketch the logarithmic function. Label 3 points that lie on the graph and determine the domain and the equation of any vertical asymptotes. So the logarithmic function that we're trying to graph is g of x equals log base 1/12 of x. So I've got a chart here, and we're going to find some ordered pairs that are on this graph. But because logs are typically new to us, I'm going to use a strategy of switching this to an exponential equation. It's much easier to find the ordered pairs in exponential form than logarithmic form. So first of all, recognize that g of x is the same thing as y. So this is y equals log base 1/12 of x. If I write this as an exponential, it will be 1/12, that's the base of the log, to the exponent of y. Logs always equal the exponent or the power. And then this expression equals x. So the equivalent equation in exponential form is 1/12 y, 1/12 to the y equals x. And I'm going to find ordered pairs in this form. Now typically when we find ordered pairs, we're going to be choosing an x value and finding a y. But because I rewrote this equation in exponential form, it says x equals instead of y equals. So that means I'm going to choose values for y and find the values of x. So I'll choose just a standard set of y values, -2, -1, 0, 1, and 2. We're going to substitute it into the exponential equation to find the value of x. That's 1/12 to the -2, 1/12 to the -1, 1/12 to the 0, 1/12 to the first power, and 1/12 to the second power. Well, let's start down here at the bottom. They're a little bit easier. 1/12 to the first power would be 1/12. 1/12 to the second power will be 1 over 144. 1/12 to the 0 power will be 1. And when we have a negative in the exponent, that means that you want to do the reciprocal of the base. So I'm going to change this to 12 over 1 to the first power, which is 12. And then we have the same negative in the exponent on this one. We'll make this 12 over 1 to the second power, which is 144. So this column has my x's, this column has my y's. Let's write down those ordered pairs. We have 144, comma, -2, 12, comma, -1, 1, comma, 0, 1/12, comma, 1, and 1 over 144, comma, 2. Now some of these ordered pairs are going to be off my grid, but we can get an idea of what's happening for the graph, so we can sketch the line. The 144 and -2 is way off my grid down here. 12 and -1 would be about here. Then we have 1, 0, 1/12 and 1. So 1/12 is really close to 0, and 1/44 is even closer to 0. And if we connect these points together, we get a graph that looks something like this. So you can see what's happening on this portion of the graph. It's getting closer and closer to the y-axis without ever reaching it. And that indicates that we have a vertical asymptote that happens right along this line here. That is the vertical asymptote at x equals 0. You can also see that we only have the graph on the right-hand side of that y-axis. And that's going to help us notice that the domain is going from 0 to infinity. So I think we've answered all of the parts. We have the domain of our log function, the equation of the vertical asymptote, and we've drawn a sketch of the graph of log base 1/12 of x. Solve the system of equations by substitution method. we have the system of equations 3x minus y equals 14 and 7x plus 2y equals -2. The directions specifically say to use the substitution method, and in the substitution method you want to choose one of the equations and solve for one of the variables. So you have the choice of solving for x in the first equation, y in the first equation, x in the second equation, and y in the second equation. Now, based on experience, I'm going to choose to solve for the y in the first equation because it doesn't have a coefficient. This is going to allow me to avoid having fractions in my expression. So I'll start with that first equation, and I'm solving for y, so I'll subtract 3x on both sides. That gives -y equals -3x plus 14. And I'm going to divide by -1 to isolate that y. That gives y equals 3x minus 14. So once I've solved for one of the variables, I'm going to substitute that expression into the other equation. So this expression of 3x minus 14 equals y. So I'll substitute it in for y in the other equation. That's going to give 7x plus 2 times 3x minus 14 equals -2. This gives me an equation with only one variable, and I'm going to be able to solve this equation. So I'll use the distributive property and distribute that too. That's 7x plus 6x minus 28 equals -2. I'll combine like terms. 7x plus 6x is 13x minus 28 equals -2. I'm going to add 28 to both sides. Now I'm trying to isolate the variable on one side. That gives 13x equals 26. And divide by 13 gives me x equals 2. Now the solution to a system will be an ordered pair that satisfies all of the equations in the system. So right now I have x equals 2, which is only the x coordinate of that ordered pair. I can find the other coordinate by substituting this value of 3 in for x here, or here, or here. Any of them I'll be able to solve for the y. The easiest will be this bottom one here. So if x is equal to 3, y is equal to 3 times 3 minus 14. 9 minus 14 would give me a -5. So the ordered pair 3, -5 is a solution to that system. And we found it using substitution. Now, one final thing you can do here is to check your work. So this is an optional step, but it's very good for testing to make sure that you haven't made any simple arithmetic mistakes. And you're going to check this ordered pair in each of the equations. So in the first equation, we have 3 times 3 minus -5, and that should come out to be 14. So we have 9 plus 5 is 14, and that is true. Then we're going to check that in the second equation. 7 times 3 plus 2 times -5, and that should come out to be -2. So we have 21 minus 10 equals -2. So that didn't work. So let's see if I made a mistake somewhere. Okay, so it's a good thing that we checked there, because right here I said that x is equal to 2, and I used the value of 3 instead of 2. So let's make that correction. So let's change this 3 to a 2. And I'm going to change this 3 to a 2. So I have 2. 3 times 2 would be a 6. And 6 minus 14 will give a -8. So now we have the ordered pair 3, -8 as our solution, and let's check that. Made the mistake again. That should be 2, -8. So we're going to check 2, -8. We have 3 times 2 minus -8. 3 times 2 is 6. Plus 8 will give me 14. Let's check the second equation. 7 times 2 plus 2 times -8. That should come out to be -2. We have 14 minus 16 equals -2. And that does come out to be -2. So now we have the solution to our system of equations being 2, -8. Together, teammates Pedro and Ricky got 2,676 base hits last season. Pedro had 280 more hits than Ricky. How many hits did each player have? So we're going to solve this using a system of equations. And I'll start off by identifying what my variables are going to represent. So we have Pedro and Ricky, and we want to know how many hits each player had. So the hits for Pedro, I'm going to let that be X. And the hits for Ricky, I'll let that be Y. In the first sentence, it says that together these teammates had 2,676 base hits. Together indicates that if we add their hits together, we're going to get that total of 2,676. So that gives us one of our equations in the system. X plus Y equals 2,676. Then in the second sentence here, it says Pedro had 280 more hits than Ricky. So Pedro has 280 more than Ricky. And if I use the variables that I set up for this, I have X is equal to Y plus 280. This gives me the second equation in the system. So I want to solve the system, and as I look at this system, I think solving with substitution is the best method because I already have one of the variables solved for. I have X equals. So I will take this expression and substitute it into the other equation. So that gives Y plus 280 plus Y equals 2,676. I'll combine like terms. That's 2Y plus 280 equals 2,676. Now I want to solve for Y. So I will subtract 280 on both sides. That gives 2Y equals, and I've got 6. I need to borrow from the 6. 17 minus 8 is 9. 5 minus 2 is 3. And I'll divide both sides by 2 to get Y equals 1 1, 9, 8, 1,198. So I have that Ricky has 1,198 hits, and I will substitute that into this equation over here to find out how many hits Pedro has. So x equals 1,198 plus 280. That is 1,000. Maybe I have to do this stacked up so I can see everything lined up. 1,198 plus 280. That is 1,478. So Pedro has 1,478 hits, and Ricky has 1,198 hits. Thank you for checking out my videos. Have a great day.